this is the demo for the setup with the ABB ACS880 speed drive for induction machines, which we've been using to show electrical drive applications, focusing on simulation step level details to our customers and potential customers. So here's the agenda of how the presentation is structured. I have prepared only 3 main topics to go over. First, I'm going to present the setup. Then I'm going to go over the schematic. And finally, I'm going to show the SCADA panel and simulation of the setup. So this setup consists of the following parts. First, a commercial ABB drive for induction machine was taken. And from it, the control block was extracted so that it could be connected to one of our Hue devices. The Hue device that was used in this setup is the Hue 404, which can simulate power circuits with simulation steps as low as 200 nanoseconds. And finally, to make the interface between these 2 parts, an interface board was designed by our partners, Dr. Andreas and Thomas. And this board can be seen as this red PCB. And what it does is roughly it makes sure that the analog signals from the model, like output currents and DC bus voltage, are read correctly by the ABB controller. And it also adapts the trigger signals that are sent from the control board to the Hue device and operates the inverter. So bringing them all together forms the setup, which I will now explain in more details, starting by the schematic model. So the schematic is oversimplified in this slide so that only the essential power components are shown. It consists of, firstly, the 3-phase input voltage source, which is connected to some inductance and a few measurements. A 3-phase diode rectifier that will convert the AC input voltage to a DC bus. The DC bus that will feed the 3-phase inverter, which in turn feeds the induction machine with squirrel cage. The most important analog signals that are sent to the controller are the 3-phase output currents and the DC voltage. This is the SCADA panel that was created for the simulation and will allow us to manipulate and monitor the simulation in real time. It is here in SCADA where we'll perform this sort of manual testing in real time. The panel consists of the following parts. First, the inverter measurements. It consists of several gauges which display the amplitude of the signals related to the simulated plant. Electrical power measurements display the input and output powers. The control panel, which consists of several widgets that allowed for interaction with the plant in real time. Oscillography consists of trace graphs that show some important variables such as motor speed and bus voltage. And finally, tests and faults. It consists of a few buttons that allow the emulation of the fault conditions in the motor, such as short circuits in the inverter switches, right through power loss, over voltage, or overload test. I would like to show now a short video that was recorded, and it shows the real-time simulation and interaction with the setup. So here the simulation is running, and you can see that the setup is energized. The button in the HMI is pressed to start the circuit, and then you can see that the signals in the scope start taking form until they get in steady state. So the interaction with the circuit is also realized through the HMI. For example, here the speed reference will be changed, and you can see that the value of the gauge, that the new value is now shown, so around 400, 500 RPMs. Another action that can be taken is to invert the direction of the motor rotation, which is done here, and you can verify that now the speed is has a negative value. And finally, the speed reference is once again changed to a positive value. So once the signals are again in steady state, I would like to show a change in the load of the motor and capture some signals to show their behavior. So just a few moments so that I can set the capture process. And with the capture process running, a new value for torque can be set, which is done by changing the slider value. And now it's just wait for the results to be plotted and analyze them as much as we like. Okay, here the torque is once again changed to 100% of the machine nominal value. And to finish the video, some fault conditions were applied to the system, starting with overload ride-through tests, which applies 3 times the nominal torque to the machine during 20 seconds. And during this fault, we observed that the machine speeds dropped to 0. If the time during which this fault occurs was longer, the drive should throw an error to protect the system. But by the end of the fault time, the system goes back to the nominal value. And one last fault that is emulated is a short circuit fault. This fault will force one of the converter switches to 1. And at this time, we expect that the drive shuts down immediately. So by clicking on this fault, we can observe that the system is indeed shut down. And in the HMI in the camera that's going to appear soon, it's showing that an error occurred and the system needs to be restarted now. Okay, so with that, I close my presentation and thank you for your attention. And I give you the floor back, Matt or Daniela.